our final equation of cosmic expansion is going to be the acceleration equation. So the fluid equation above here is giving us something which links the energy density with the scale factor and the pressure. So that's quite useful. We'll see why in the next lecture. But we would also like a final equation, and that's going to be the acceleration equation. So if I take the Friedmann equation, and I just multiply it by a squared, it becomes a dot squared equals 8 pi g e a squared over 3c squared minus kc squared over r naught squared. And now I'm going to differentiate with respect to time. And that's of course important because I've got acceleration. So here I have an a dot. That's basically a velocity. I want an acceleration. I need to differentiate it again. And I need to bear in mind here that when in this first term, I have two things which are a function of time potentially. So I have an energy and a scale factor, both of which are functions of time. So I need to differentiate both of those. To get this. And this second term, well, as we saw earlier, if the universe is flat, it's flat forever. If it's positively curved, it's positively curved forever. If it's negatively curved, it's negatively curved forever. So the d by dt of that term is equal to 0. So I'm only worrying about this one. And now I tend to normalise things by the scale factor at the current time. So if I just divide by 2a dot a, then this becomes a double dot over a equals 4 pi g e over 3c squared times e dot a over a dot plus 2 epsilon, or 2 e dot. And then this bit here, well, this looks a little bit familiar because these are terms that are in the fluid equation. And so the fluid equation says the following. It's above us anyway, but I'll write it down here. E dot plus 3 a dot over a e plus p equals 0. Or e dot a over a dot equals minus 3 e plus p. And if I substitute that in to this equation here, then what I get is a double dot over a equals minus 4 pi g over 3c squared e plus 3p. And this is the acceleration equation. And as the final thing we need to do all of this together, and that's so-called equations of state.